Good morning. This is Professor Gardetto, finishing up week 7 with a mini lecture on homework number 21. You'll notice also there's a quiz 6 on Connect Math that'll be available for you to take only after you get done with 19, 20, and 21 on Thursday. All the assignments are due on Sunday, August 1st by midnight. So I'm going to preview this assignment here on Connect Math. And here we go. We talked a lot about the log loop yesterday. The equations that if they're given to you in log form, we want to put them in exponential form. And once you put them in exponential form, I believe the answer will be obvious. Remember, if we don't see anything here, this is an x. And once we solve for x, we're done. Remember the log loop? Hopefully the log loop, hopefully you saw the lecture and the mini video from yesterday. But the log loop goes this way. This is the log loop I'm talking about. So we say the base is 2. The exponent is x. And it equals to 2 to the 4th. And what obvious means is if 2 to the x equals 2 to the 4th, it's obvious that x is equal to 4. So that's what we put in the box right there. Okay. The problems that are not given to you in log form that one's in log form. Let me look at one that's not in log form. Okay, so this, even though you see the log, but the log is in the wrong spot. This is problem number 6. This is an exponential form. Okay, so in exponential form, we've never seen a log as an exponent before, but we kind of go and do this the same way. We put x here, but now we write it as a logarithm. Okay, so we write the word log. What's the base here? The base of this exponential is this 6. So remember that 6 goes right here. Okay, and then the x goes here. And we'll check this by doing the log loop. And the exponent goes on the right-hand side. So the log loop, 6 raised to this power is equal to x. And that's exactly what this exponential says. Okay, and now this answer is also kind of obvious because they're both log base 6s. So if they're both log base 6s, then this x is got to equal 12. So we put 12 in the box right here. And that's how these problems from 1 through 11 go. They're either given to you in exponential form, and we change them to logs, and the answer is pretty obvious. Or they give it to you in log form, and we change it to exponential, and the answer is pretty obvious. Okay. So starting on 12, this is what we kind of ended the lecture yesterday talking about, is how to solve exponential equations when you can't make the bases the same. 3 to the p equals 76 is problem number 12. You'll get one similar to it. So what I want to talk about before we use logarithms to solve this is I want to talk about some properties of logs. Okay, there's three properties of logs. The first one's called the power property. And let me give you an example, okay, of a log that we should know. The log of 10. The log of 10 is equal to 1. Okay, remember there's a 10 right here. And if we go like this and put the x on this side, this is called a common log. 10 to the first power is equal to 10. So we know the log of 10 is equal to 1. Okay, log of 10 is equal to 1. Okay, usually you don't even see this 10 right here, so I'm not going to write the 10 anymore. We'll just say log of 10 is equal to 1. So what if we had the log of 10 squared? The log of 10 squared, well, that's equal to the log of 100. And the log of 100 is equal to 2. Because 10 to the second power is equal to 100. So what the power property tells you could do, and this is really important to solve this equation, we're going to use the power property, is we can take this exponent 2 and move it in front of the log. By moving it, I mean you could actually write the 2 out in front and then write log of just 10 instead of 10 squared. And this is still equal to the same thing. It's still equal to 2 because what's the log of 10? The log of 10 is equal to 1. And 1 times 2 is equal to 2. Okay? This is called the power property. Okay? The power property says the log of any base, I'm just going to leave the base 10, of m raised to the n power is equal to n, the exponent, times log of m. You guys might want to write this down, this property right here. There's 3 log properties, only 3. This is the first one. Okay, it's called the power property. The reason why it's called the power property is it allows you to solve for a power. A power is another name for an exponent. It allows you to solve for this exponent. So what we can do is use this property to solve this equation. Okay, now we always check to see if we can make the bases the same first, because we can make the bases the same, then we don't have to use logs. But there's no way of making 76 a base 3. 76 isn't a number that is a multiple of 3. So what we do is we take the log of both sides. And so I just write the word log in front of the 3p. And I write the word log in front of the 76. Okay. So now we use the power property because we have to solve for this variable, and the variable is an exponent. And it's really difficult to solve for an exponent unless you take the exponent and move it out in front. So we're going to put the p in front of the log 3. So that just means this is p times log 3. And this still equals log of 76. Okay, so now we have to solve for p. We have to solve for p, kind of like you solve for p for an equation like 4 times p equals 12. We divide both sides by 4. Well, in this case, we divide both sides of the equation by log 3. Okay, these log 3's cancel. And we have P equals, and this right here, we could actually put in our calculator. However, the directions are to write your answer in exact simplest form. This is exact simplest form. They don't want you to go into decimals. Okay. The number is going to be a decimal, 3 to the, and we did this yesterday, 3 to the third power is equal to 27. That isn't even close to 76. And 3 to the fourth power is equal to 81. Well, that's a little bit above 76. So the answer falls somewhere in between 3 and 4. Probably closer to 4 because 76 is closer to 81. So it's going to be like, if I had to guess, it would be like maybe 3.8. But that's just a guess. It might be 3.7. It might be 3.82. If you put this in your calculator, I'm not going to do that right now, but if you put this in your calculator, you would get some decimal that starts with a 3. But it's not going to be just 3. It's going to be 3 point something. What you do for Connect Math, because remember decimals aren't allowed, simplest form is this expression, log 76 divided by log 3. So what we do is we click this and you'll see a fraction bar. And then you'll see in the top left corner, you'll see a log. So click log and then just type in 76. And then on the bottom, make sure you click log again because you have a log over a log. And this is 3. And then you can check your answer. There we go. Took a little while to get that green check mark. Okay. Yeah, before I erase the screen, make sure you copy down this property, the power property. Okay, I'm going to go ahead and clear it. And let's look at problem number 15. Okay, so this one here has two bases. It has 2 h's that are exponents. Again, we're gonna solve this similarly. We're gonna take the log of both sides. So I'm gonna go log. I'm just gonna write log here. I'm not gonna rewrite the problem. I'm gonna write log there, and I'm gonna write log here. Okay, so log in front of both sides. So now I'm going to take the exponent, which is h minus 1. Okay, I'm going to keep this h minus 1 in parentheses because it's a binomial. And that is written out in front, and this is times log 9. Equals, and I'm going to put this h out in front, and this is times log 4. Okay. So anytime we have parentheses, we have to distribute. Okay. Just think of log 9. Log 9 is just a number. Okay. You could actually plug that in your calculator and find out what the log 9 is. Okay. It's some decimal. But we have to distribute this log 9 to both the h and the negative 1. So this is going to become h log 9 minus 1 times log 9 is just minus log 9. and this equals h log 4. Okay, now we have h's that we have to solve for. We have to solve for h, but we have an h on both sides. Remember when we solved equations and we had h's on both sides? If we had variables on both sides of an equation, you have to get the variables on one side. So I'm going to take this and I'm going to subtract it. Now the log 4 comes along with the h. So I'm gonna keep this h log 9, h log 9 there. I'm going to subtract the h log 4. And I'm going to bring this over to the other side. So minus log 9, I'm going to add log 9 to both sides. So this is log 9. Okay. So not to confuse you, but I did two things at once. I brought this over here, and I brought this over here. And the reason why I did that is I wanted to get the h's on the same side. Now, if we have two h's and we have to solve for h, and I can't subtract these two, what we do is we factor out the h. The h is common. So remember our factoring skills. Our factoring skills are going to help us. So this is h times log 9 minus log 4. And this still equals log 9. Okay, now we're really close to solving for h. Really close. All we do is we divide both sides by what's in parentheses here. Log 9 minus log 4. Log 9 minus log 4. Okay. Now don't you dare cancel those log 9s. They look the same, but there's a minus log 4 here attached to this log 9. So this is really your answer. It's a lot to put in, but it says exact simplest form. It doesn't say decimals. So when you put your answer in, you put log 9 on top, and then on the bottom you put log 9 minus log 4. Okay? That's what goes in the box right there. All right, that was 15. Let me see, 18. Okay, well, 18's just got an equation that's in log form. Okay, so this is going back to yesterday. This is log loop time. Log loop time, because we have a log. We can't really solve it unless we get it into an exponential. So this is the log loop. The base is 4. The exponent is 3. The number is c. Well, all we have to do is find out what 4 to the third power is. 4 times 4 times 4, I believe that's 64. So we just put 64 in the box. $64. I'm going to see if you can put 4 raised to the third power. See if they want you to multiply it out. Nope, you don't have to multiply it out. I think they would also accept 64, but you also can put 4 to the third. Okay, no properties of logs other than the log loop that we had to use there. Okay, 23. Okay, last 3 problems. Okay, Equations that have more than one log in them. Remember I told you there was 3 log properties? Well, there's a property for adding logs. And let me show you where this one comes from. And again, let's use our common log, log 10, that we know is equal to 1, right? We know that's equal to 1. So let's say I had log 10 plus log 10. If I had log 10 plus log 10, we know this is equal to 1. We know this is equal to 1. So this is equal to 2. What do you think you do to the numbers here when we add logs? Do you think you add the numbers? Do you think you write it as log 20? Is log 20 equal to 2? No, log 20 is not equal to 2. So what else can we do to these? Well, what we do is we multiply these together. 10 times 10 is 100. Log of 100 is in fact equal to 2. It's kind of like exponents. Remember logs and exponents, there's a relationship. When you multiply, you have to add exponents, right? When you multiply, like x squared times x cubed, you add exponents, so you get x to the 5th. Well, when you add logs together, as long as you have the same base, both these are base 2. So when you add logs together, you multiply the numbers that you're taking the log of. You multiply them, and you could write it as 1 log. So you can make 2 logs into 1 log. So this is the property. Log of m plus log of n is equal to a single log m times n. I'll just put mn. This is the one you want to use for this one. You want to write that down. That's the second log property. So to solve this, we simply write this as 1 log, but make sure you write the base down. Right? The base is 2. And we have k minus 3 times k plus 3. K minus 3 times k plus 3. If I multiply k minus 3 times k plus 3 in remember the box problem, I get k squared minus 9. When I multiply those together, I'm going to leave it in parentheses. And this equals 4. Okay, if you have to do the box, do the box. K minus 3 times k plus 3. K squared minus 9 when you multiply that out. Okay, so now we have 1 log equation. It's log loop time. 2 is the base, 4 is the exponent, equals k squared minus 9. 2 to the 4th is equal to 16, equals k squared minus 9. This is a quadratic equation that we talked about last week. We don't have to solve this by factoring. We could solve this by the square root property. Add 9 to both sides. That's 25. 25 equals k squared. How do we get rid of a square? That's right. We square root. We put the plus or minus sign in, right? Don't forget that. And we have k is equal to plus or minus 5. Now, we talked about taking logs yesterday of negative numbers in the, I don't know if it was a mini video or if it was the lecture, but we can never take logs of negative numbers. So even if you forgot to put the plus or minus sign down, you can't put -5 into this equation because -5 would make, well, it would make both these negative. So the answer is not -5. The answer is only +5. Okay. Put that number in the box. Just +5. Check your answer. Okay. Make sure you write this property down. It's the addition property of logs. (24) 24 has a log equation. Now, we haven't seen these logs before. Let me just talk a little bit about if you see a log that says ln. There's the regular log, and we know the regular log is a log base 10. You never see the 10, right? But if you see an ln is actually a log, but it's a log with a different base, and the base is equal to e. There's actually a number that is, it's kind of like pi. You guys have seen pi before. Pi looks like this. Pi is like 3.14. Well, e is actually a number 2. It's a 2.718, I think it starts out with. But instead of saying log base e, they have a notation for log base e's, and it says ln, and it stands for natural log. You really don't need to do anything differently. You just got to put ln instead of log when you type it in. The property that we have to use in this one, though, is and plus there's 3 logs here. Okay, so this is a little bit different than 23 because 23 only had 2 logs. 23 had just 2 logs. 24 has 3 logs. Okay, and plus there's a minus sign there. Okay, so let's talk about the property of subtraction. And let's use our good old friend log base 10 that we know is 1, right? So let's say we had log base 10 minus log base 10. Well, log base 10 is 1. So this is 1 minus 1. 1 minus 1 is always 0. So what do you think we do with the 10s when we subtract? Well, remember when we added, we multiplied these two, right? When this was an addition sign, we multiplied these two. What's the opposite of multiply? Yep, divide. So we divide these. 10 divided by 10. 10 divided by 10 is 1. The log of 1 is actually, in fact, 0. Check it on your calculator if you want, but this is a base 10. 10 raised to the 0 power is equal to 1. Remember, anything raised to a 0 power is equal to 1. So here's the property. Log m minus log n is equal to log m over n. Okay, it's the subtraction property for logs. We don't subtract, we divide. We divide the numbers that we're taking the log of, as long as we have the same base. Okay? So, if you have 2 logs on one side of an equation, you want to combine them as 1 log. So I'm going to use ln, and I'm going to divide y plus 4 over y. Don't you dare cancel those y's, because the plus 4 is attached to the top one. Okay, and now the equals natural log 3y. Doesn't really matter if you leave it in parentheses or not. I'll go ahead and leave it in parentheses. Okay, so here we have a natural log. We have a log on the left side, and we have a log on the right side. If we have a log on the left side and a log on the right side, these two have to equal each other. These two have to equal each other. Okay, so let me make some space here. Okay, so if they have to equal each other, then we just write that equation. Y plus 4 over y equals 3y. So basically these logs go away because we have a log equal to a log. So how do we solve this? Well, I want to get rid of this fraction, so I'm going to multiply both sides by y. Multiply both sides by y, the y's cancel. So I have y plus 4 left on one side. And I have 3y times y is 3y squared. This is a quadratic equation. Can't really solve it by the square root property because you have a y right here. So I'm going to, let's see, I have 4 different methods to solve quadratics. Factoring is always the easiest. So I'm going to see if this is factorable. So I'm going to subtract y and subtract 4 on both sides. So this is 0 equals 3y squared minus y minus 4. And remember, to see if this is factorable, we do the diamond. We do 3 times negative 4 is negative 12 and negative 1. Okay, let me get some room here and just erase this part here because we use that property already. Okay, so this is going back a couple chapters. We're now solving a quadratic equation that resulted from our log equation. So I think we could use grouping here. 3y squared. Multiplies to get negative 12, adds to get negative 1 would be negative 4 and positive 3. So negative 4y plus 3y minus 4. So I'm going to group them first two, last two. And I think we are going to have the same thing in parentheses. This is 3y minus 4. And we have a 3y minus 4, which is good. So now we can go ahead and factor it. It's 3y minus 4 times y plus 1. Remember, this is equal to 0. So our two answers are 4/3. That's what makes this 0. And negative 1. Now, we have to be careful. Sometimes the equations have 2 solutions. Sometimes they have 1 solution. Sometimes they have no solutions. It all depends on, does any of these solutions that we got make what you're taking the log of negative? See, if we put a negative 1 in here, if we put a negative 1 right here, that's going to be the natural log of negative 1, which cannot be done. So we're not going to choose negative 1. 4/3 is our only answer. So we pop in 4/3 right there. Okay? Exact simplest form would be 4/3. Okay, last problem. Clear my screen. And this is problem number 25. Okay, so we have 3 logs and they are, well, there's 2 on one side and 1 on the other side. So if there's 2 logs on one side, we're going to have to use a property and combine these two. So make sure you use the right property. That is going to be the multiplication property. So that's going to be 8h minus 16. I'm going distributed that 8. Okay, and that equals the log of 10h. Okay, so now you have logs on both sides. Well, if logs are on both sides and they're the same base, you can ignore them, and then you have an equation that you can solve. Subtract 8h on both sides, you have 2h. You have 2h equals negative 16. 2h equals negative 16. You divide by 2, and you get negative 8. That's our only answer, negative 8. However, if we plug negative 8 in, it's going to make these negative. So there should be an empty set here. Let's see. I think it's this one right here. I think that's the empty set. That's like no solutions. There's nothing inside those two. Let me check. Yep. So if you get a solution that's negative and it makes what your logs are negative, there are no solutions to the problem. Okay. So just be careful there on the ones that don't have any solutions. Hey, stay tuned for the live lecture coming up later this morning, and you should be able to get done with homework 21. Once you get done with homework 19, 20, and 21, you should be able to take quiz number 6, and then I will be talking to you more tomorrow. I'm not going to talk about new material tomorrow morning, just 8 a.m. question and answers to get you prepared for the quiz.